Okay, good morning, ladies and gentlemen. Thank you, Chair. My name is Dawn Mahlobo. I'm coming from the South African Weather Service. I'm the Senior Manager Climate Services there. I'm responsible for 4 units, one pertaining observations and assurance. The other one is data management, that includes your quality control of observations. We also have a unit where we do research and analysis using our climate data. And the 4th unit is the dissemination. So that is where we reach out to our clients. We have both public good and commercial clients. So today I'm just going to briefly talk to you about this, the climate service infrastructure we have at SAWS. And I won't only stick to SAWS, but to other entities that also have climate services within South Africa. So as you can see, this diagram, so this is the seamless forecast that we produce at SAWS. It starts from the network and technical infrastructure. So for everything with us, you need to have a very well-maintained ICT infrastructure, as well as the technical infrastructure, and it will go down to your observations. So we have observations network. Across the country, we have a number of stations, both observations and remote sensing stations. I will divulge this later on in my presentations. And then we also have this, when you have all of this set up, then we have your seamless forecasting system, that is your meteorological, climate, and applications modeling. So if you see in this picture here, everything starts well off with a good historical observations or data or climate data on the ground. And then we have then your weather forecast. So from the scale of minutes up until a week. So we have your alerts, your warnings, and your forecasts that we issue free of charge to the public. And then from there, from the weather, we have now your climate variability, starting from a scale of 2 weeks up until years. And then we have your outlook predictions, your seasonal predictions and so forth, and up until the climate change. That is the scale of your decades and centuries. So as you can see that these black lines, that shows the forecast uncertainty as your scale increases. So in areas of minutes and hours, you can really see that we do have a very low forecast uncertainty. So we are very, very, very certain about our forecast. But as the scale goes up, so does our forecast uncertainty. So this will feed off to a number of services that we offer. So we have your government services as well as the non-governmental services. The government services include your public services and your specialized services that we issue to the government. This includes the reports, your climate risk reports, climate change adaptation reports, and all of that, as they are needed by the government, because we are the technical wing of the Department of Environmental, Fisheries, and Forestries. And then also have other services that we issue. For instance, your impact early warning systems. These are some of the services that we issue through our disaster management structures within the country. We also have non-governmental services. That includes your industry. So we service a lot of industry, from your insurance industry, your constructions industries. So we do have lightning reports, so that we issue every time there's thunder. The insurance will be sitting on our shoulders to give them the reports, because people need to claim for insurance, and then they need that assurance that there was lightning or there was hail during that period. And then also have your downtime reports, your rainfall return periods that we issue for the construction industries. We work closely with the legal systems when coming to court cases. So whenever or whatever court case is there will always going to be an element of weather. You're talking about kids being struck by lightning on the ground. They'll come back to us if there's a cases to really verify that there was lightning during that time. Or maybe just someone deciding to murder his or her spouse. So there will be an element of weather there. We need to verify the weather conditions, because every time they will blame things on weather, we must be there to verify those typical conditions. And at Weather Service, we also have different units that talk to weather applications or climate applications. We have a unit that talks to energy, a unit that talks to agriculture, to hydrology, to a number of sectors. So we do have sector-specific products that we offer to different industries. And other services that are tailor-made for specific clients, but we do charge for such services. So they fall under our commercial space. Okay, it's not moving. Okay, so the World Meteorological is part of the South African Weather Service is part of the World Meteorological Organization. So the World Meteorological Organization is a global body that coordinates climate services globally. And it establishes standards that national meteorological and hydrological services must adhere to in order to provide climate services. So as the South African Weather Services, we are part of the national meteorological services that report to the WMO. Other countries, they have your NHMSs as one organization. But here in South Africa, we have the Weather Service that will be part of the National Meteorological Services, and then we have the Department of Water and Sanitation that will form part of the Hydrological Services. And together, we are the National Meteorological and Hydrological Services, and report and adhere to WMO standards. So the WMO global infrastructure is composed of the three main components. Number one is the WMO integrated global observing system that talks to the operational and research funded subsystems, including your physical observing infrastructure on land, at sea, in the air, and in space. So we have observations on land, on sea, in the air, and in space. So all this infrastructure you'll be seeing today, they form part of the WGOS, that is the WMO Integrated Global Observing System. We also have the WMO Integrated Processing and Prediction Systems, and this talks to your analysis, your forecast, your alerts, your advisories, your climate change predictions, and so forth. And lastly, we have the WMO Information System, that is the WIS, and that is a technical framework for exchanging meteorological and related data and products. So as part of the WMO, or as an NHMS, we need to share data. The data that we share is used or as inputs to the global circulation models. So for your models to predict weather better or climate better, they rely upon good observations on the ground. So as South Africans, we do adhere to this WIS, and we contribute to around 200 stations, data from 200 stations on a daily basis that is sent to the WMO via the GTS system. And other countries, so as other countries, some of the countries in Africa, who are the best in Africa, just to manage to send stations of about 200. Other stations, other countries, they will send 5, 7, depending on their capability. So we're really good in the continent, but globally, that is where we're lacking. Remember when there was fees must fall at some point, there were those type of kids that were called missing middle. I think we're also the missing middle here. Locally, we are good, but globally, we're still trying to find ourselves. So when there's potential funding from the WMO, they will say, no, South Africa, you're doing well. You don't need anything. You can do well. Whereas we are, but compared to them, we are really struggling. And we are the big, we act as the big brother or big sister to our neighboring countries, to the whole of Africa. Just a history of the South African Weather Service. It was formally recognized as a public entity following the announcement of the South African Weather Service Act number 8 of 2001. Remember, before then, we were part of the government, we were the South African Weather Bureau, but as time goes on, it was decided that we stand as an entity on our own as South African Weather Service. So This was amended in 2013 to refine our mandate and operational framework. So from 2001, we were concentrating only on weather and climate. But from 2013, now we started adding air quality as part of our mandate. So now we have a fully fledged Office of Air Quality. We do observations, we do modeling of air quality across the country. So this is a snapshot of our observations. So we have a number of automatic weather stations across the country. When we talk about automatic weather stations, it's those stations that are automatic and they measure your rainfall, temperature, pressure, wind direction, wind speed, and humidity. So we have 268 of those in the country, and we also have 172 ARSs, similar to the AWSs. We have ARSs, they function the same way as the AWS, but they only measure rainfall. So the highest resolution you can get the data for these two is 5 minutes. So the data in 5-minute intervals is available on our database. So this picture, this is not only the network of South African Weather Service, but it also includes that of ARC, the Agricultural Research Council, as well as SAWS. So collectively, as the three organizations, we have around 936 automatic weather stations. So 268 from South African Weather Service. We have 615 from Agricultural Research Council, and from SAWS we have 53 AWSs. And then when coming to ARSs, we have 172 from SAWS, we have from SAWS we have 70, giving a total of 242 within the country. We also have 892 manual rainfall stations. So manual rainfall stations, they're not automatic, so they need someone to go and observe on a daily basis. And we rely upon volunteers and observers, your citizens, to observe these parameters. However, this value is decreasing daily because now we don't have enough volunteers anymore. People are getting old. The people that like to observe, they're getting old. Some of them, they are passing on. And the younger generations, they don't want to do things for free. They don't really see the value of taking weather observations, which is a challenge in the country. But however, as the South African Weather Service, we are trying to convert all these manual stations into automatic weather stations. It is not easy. It is very heavy on the pocket, but we are trying as much as we can do. So, and then we also have the radiation, the GO, and the biomet network in South Africa. So we manage a network of around 13 solar radiation stations in South Africa, and then the data dates back to 2013, so we don't have much of this data set, but we're trying. So what it does, it helps us to quantify the potential of contribution of solar energy resources to improve national energy security in the country. And then we also have the BioNet network. So this one, the BioNet network, is more of having your automatic weather stations plus your air quality. So it will have all the parameters that you get from the automatic weather stations, as well as air quality parameters. So in the Cape Pond station, we have a station like that, and then it is one of the two stations that are there worldwide. And it has been operating since 1978. And what is measured there is your carbon dioxide, your methane, your nitrous oxide, trace gases such as carbon monoxide, surface ozone, gaseous elementary mercury, halocarbons, and aerosols. So we do have challenges with our network. And some of them, it is due to understaffing. We don't have a lot of people. As I've said earlier, that when coming to manual stations, we relied upon volunteers, and we're losing these volunteers as they're aging and some are passing on. And they're a younger generation, they don't really want to do things for free. And the staff that we have is quite limited, but we have a huge challenge on our shoulders to make sure that we do provide climate services in the country. And even the challenges regarding the distribution of networks. So we don't have all the stations in the areas where we would like to have. mainly because some of the land is owned by private people, and they feel that they don't want to have a station within their land, and which is understandable. So these are some of the challenges as SAWS network. As you've shown, as I've shown in the earlier images, this network is not so dense, particularly in the northwestern parts of the country, because maybe then we assume that this is a desert area of South Africa or semi-arid area of South Africa, so we don't have a lot of stations there. But now there is that appetite of stations because of the abundance of solar that is in those areas. The long-term observations. So our data go as far back as in the 1800s. However, because we're closing stations and sometimes because of the land being purchased by people, so we have to change stations, we have to change the location of the stations, and in that it disturbs the long-term observations. So instead of having maybe more than 100 years of worth of data continuously, we'll have gaps because now we have to move from one location and redirect the station to another location, which disturbs the long term of our observations. And another thing is equipment with urgent needs for repair maintenance with limited. We don't have budget. So maintaining a weather station across, or weather station across the country is not pap and place. It is quite expensive, and this is quite a challenge. Vandalism of instruments close to communities. People are hungry. So sometimes when they see a weather station, they see something that can exchange to get something to feed their tummy. So it is quite a challenge. And also they importing these instruments because they are imported, and then the exchange rate sometimes can be very unfavorable for us. So it does pose such a challenge. So I've tried to compare the infrastructure of the ARS and WS we have in South Africa compared to Rwanda. Rwanda has a land mass of around just over 260,000 square kilometers. In South Africa, we are more than 1.2 kilometers square meters. However, we have 242 ARSs in this large area, and then Rwanda has 100 stations. AWSs, we have around 936 stations. Rwanda has 71. And you can really see that things are not adding up here. Let me just rush, I don't have time. We also have weather radars. We have around 12 radars across the countries. They are covering all the areas. We have C-band and S-band radars, and the resolution of these radars is 6 minutes. So we have radar data at 6-minute intervals. The spatial range is around 200 kilometers radius, and it is scanning at 360 degrees. And this is the primary tool that we use for nowcasting. And remember, with nowcasting, not only focusing here on South Africa, but also helping our neighbors in Swaziland, in Maputo, in Lesotho. So this is quite an important thing that we have. So I want to write. So the polarization, the challenge that we have with our radar, when coming to polarization, we're using a single polarization. And if you look at the other developed countries, they're using a dual polarization. And the advantages of using a dual polarization is that it improves the precipitation identification. You can identify the type of precipitation. You cannot just say these are rain droplets. When they are not, they are just cloud droplets. So it can make that distinguish. It can distinguish that. It has an enhanced accuracy in rainfall estimation. So you can really tell how much of rainfall is there. It can detect hail, very good, and then it does reduce the non-meteorological clutter, which is almost predicted or that we see from our radars, and it also have it improves the severe weather detection. So in this slide, I also compared the land area of South Africa to that of Great Britain, which is around 200 square kilometers. We are more than 1 million square kilometers, but we have only 12 radars. They have 14 radars. So you could see even here that things are not matching up. We still have a long way to go. Let's look at our lighting detection network. We have 26 sensors across the countries. So the lightning data is available within seconds the event occurs. It covers the entire country. It's available in different formats, and then it goes back to 2006. Even with our lightning detection, we're not only focusing on South Africa, but we also we help Swaziland, Mozambique, and Lesotho. So this is an example of the density of our lightning density map. You can see over the eastern and northeastern parts of the country, that is where we have a lot of lightning, but as you go westwards, then the intensity of lightning or the occurrence of lightning, it decreases. So our sensors, they really concentrate on the cloud, on cloud to ground. Remember, we have cloud to ground lightning, we have ground to cloud lighting, we also have lighting that occurs within the clouds. So our sensors, they only concentrate on cloud to ground, but we can also capture some of the in-cloud lighting that occurs. Let's talk about other infrastructure that we have. We have a severe weather impact database. So I know that most of you are familiar with the KLAM. It used to be in a hard copy, so it had a list of events that have occurred, the severe weather events that have occurred over the country. We moved from the hard copy to an Excel spreadsheet that is geocoded, but still there are some limitations in this type of publication, although it is a selling point for weather service, but there are some limitations because some of the people that will report these severe weather events are journalists, so they will see a rainfall occurring and they'll say, okay, there was flooding in a particular place. But when you trace, it was not flooding, but it was only heavy rainfall. And sometimes they'll say maybe flooding in Pretoria. Where in Pretoria? You don't know. Pretoria is quite big. So these are some of the limitations that we've found in the KLAM. However, now we're starting to establish a severe weather impact base where we're not only focusing on the event itself, but even the impacts that the severe weather has, and also the weather systems that are surrounding or that are responsible for this event. For instance, when you're talking about flood, what systems are you talking about? There was an upper trough, was there a reaching high, and all of that. So all of this analysis is captured in this new data management system. It is still in progress, it's still a work in progress, but we're getting there. We also have data rescue projects that are implemented at SAWS. As you know that we have data that is, okay, just give me a minute or two, data that is in hard copies, dating back at 1800s, 700s, that is still in hard copies, that is not in the database. And that is valuable data. So what we're doing here, we're trying to employ AI into capturing this data. But our AI at some point, it is failing us because some of this data, it is written, the handwriting is quite bad, and some of them, it is cursive. And the AI can't pick up those type of things. So we need human people to come and capture those those type of data. The integrated data management system, you've seen our network. So the current data management system that we have, it concentrates on the point data, only on the observation data. But we want to go further and try to include all the data that we have in the organization to be included in one data management system. So we will have your station data, your satellite data, your radar data, even your modeling data to be housed in one so that it will be easy for us to work with the data. So that is our integrated data management system. Because we love our community so much, we've tried to translate whatever we do in local languages. So we have a number of 500 words, severe weather words that we've translated in isiZulu, isiXhosa, all Africans, all South African languages that we're trying to reach out to our communities. We stopped doing weather for weather people or weather for scientists, but now we're doing weather for the community. So we're doing all these things because we love our communities. Thank you so much. I won't go to the conclusion remarks. Thank you so much, gentlemen.
Thank you very much. Yes, I was pushing her to finish Thanks for the presentation. We will take colleagues' questions at the end of this session. So this is a small thank you from Idrissa for you.
Thank you.
Thank you.
So
Okay.